Hi, my name is Alusain and welcome to this lesson on the differentiation of implicit functions. This is one of the really important aspects we have to learn before we move on to the applications of differentiation because the ideas here can confuse people very easily. Now, first of all, what is an implicit function? Well, if you see the functions we have here, you suspect something. The last one you can't see. Say we're given the function we are given x cubed plus y cubed is equal to 3x, sorry, 3xy. Okay? Say we are given such a function. It's it's impossible for us to try and isolate one of the terms on one side of the equation and express it as it in terms of the other one. Okay, so this is what implicit functions really are. For example, let's just try saying we want y on one side of the equation. Okay, if we want to do that, say for example we transpose x, which is not like, so we have y cubed here. But what would we have to do? We would have to bring plus 3xy to the other side. It changes to minus 3xy equal to x cubed. But now, although we have y common, we also have x here. So it's impossible, even if we factorize y, so it remains y squared minus 3x x cubed. We cannot divide. If we divide this, we are still going to have, so it's impossible for us to express one of the variables in terms of the other. Okay, so when we have functions like this in two variables, we're having two variables here. Okay, instead of one, as we have in functions such as y is a function of x, say example where we had y is equal to x squared, for example. Okay, such we have the function in only one variable. Here we have it in two variables in this form. Okay, so for implicit functions, it's impossible for us to express one of the variables in terms of the other. Okay, let me try and wipe this off so we can okay. Let me just clean up a bit. It doesn't seem to be going away. So the general method in dealing with implicit functions such as these ones, say for example the one we dealt with, x cubed plus y cubed is equals to 3xy, and a function such as this one, x squared plus y squared is equals to 2pxy, where of course p is a constant. Okay, so we treat it just as we treat 2 constant. Okay, so for such functions, to differentiate them, what we can do, we follow these steps. Let's come down a bit. We follow the following steps. Okay, so let me just use a different ink here. Say to differentiate an implicit function, we follow these steps. Okay, we say step 1, we try to differentiate the function term by term. Okay, we differentiate the function term by term. So each term here, this term x cubed, we differentiate y cubed, and we differentiate this other term here on the other side of the equation. Okay, so now, so we say differentiate the function term by term. Okay, term by term. And in doing this though, you have to pay attention to a few things, but let's just so first you differentiate it term by term. What you get by doing this example, because all of these functions here are in x and y, to when you differentiate it term by term, we are going to get an equation in dy dx, x and y. Okay, to get an equation in dy dx. Okay, we are going to get an equation in dy dx, x and y. Okay, in doing this, the second step would be to make dy dx the subject, okay, the subject of this equation, the subject of the equation, the equation in 1 above. Okay, in step 1 above. So this is what you do to differentiate the implicit functions. But what do I mean by this? For example, let me scroll down a bit. In fact, before we do that, let me just make a quick note here. In differentiating it term by term, say, let me use another ink. Say note, in differentiating term by term, in differentiating term by term, you have to remember that. Now, if you have y, if you differentiate y, if you have in an expression, okay, you have the value y there. To differentiate y, it's going, you are say the x of y. Okay, this is going to give us dy dx. Okay, say for example you have 3x y plus y equals to 3py. Now, to have this sort of say for example you want to differentiate this y value here. Okay, this differentiating this will give you dy dx. This is what you get for when you differentiate this y value. Okay, and also if you differentiate y squared, if you have, say for example this was y squared, differentiating this y squared, if we say differentiating the dx of a value y squared, is going to give us, is going to result in is going to give us, you are going to basically have like what we have in differentiating monomials, 2y, okay, because, and we are going to subtract 1 from the power, so 2y dy dx. Okay, similarly, let me come down a bit. In differentiating, if we also differentiate y cubed, if there's y cubed in an equation, for example, if you differentiate d dx of y cubed, what we are going to get, so always we are multiplying, so this is going to be 2y squared dy dx.